Today we're doing section 4.8 day 3, and this is the last section in chapter 4. We're going to be talking about applications of trig functions, so we're going to be going back to SOHCAHTOA today. It's important if you're using a calculator at home that you're in radians and not degrees. So we're just going to start with just a basic right triangle, just again to refresh our memories on SOHCAHTOA. So let's just jot that down at the top so that way we can reference it. So the directions tell you it's a right triangle, so I would go ahead and create a right triangle. And then you're going to label it ABC. The only one that matters is angle C because that's the 90-degree angle. Doesn't matter if you put A at the top versus B at the bottom. To interpret this information, capital letters are angles, lower cases are sides. So angle A is 34.5 degrees, so that's in here, 34.5. And then the way the sides work, sides are opposite. So for example, if angle A is at the top, that means this is side A. If angle B is on the right side, that means this is side B, and side C is over here. So now that we have that clarified, angle B is 10.5, and then again, angle C is 90 degrees. Because the directions say solve, that means I want to know everything that's missing, so we need to find angle B, we need to find little a, and we need to find little c. So to begin, the most easiest way is to find our angle B. So we would add up 34.5 and 90 and subtract it from 180. When we do that, we get 55.5 degrees. So remember, there's 180 degrees in a triangle. Now that I have that, we need to find our angle, or the two sides that are missing. So I'm just going to put my theta up here in angle A. You could choose to use angle B. Your calculations would be different. Your final answers would be the same. Based on my placement of my theta, I'm going to label my triangle with my opposite, adjacent, and hypotenuse. So obviously this is always the hypotenuse that's across from the right angle. Opposite of my theta would be down here, and side B would be my adjacent. So let's just find our opposite first. So let's find A. So if I need to find A, O, we only know side B. So I have an opposite and I have adjacent, so we have to use tangent. So I have tangent of 34.5. Oh, this didn't copy right up here. Equals my opposite side, which is side A, over my adjacent side, which is 10.5. To solve for A, we just multiply both sides by 10.5. And this is where having your calculator in radian or degrees is handy. You can just type it all at once. So you would just type exactly what you see over here on this left-hand side. And when you type that in, A will equal 7.2. So I can go over here and label, I know little a is 7.2. Now that I have that, I could switch the trig function. I could now use the opposite side. I typically like to always use the information that's given, so I'm going to stick with using the adjacent side to find the hypotenuse. So that means I'm going to be switching to cosine. So I have cosine of 34.5. My adjacent side is 10.5 divided by my hypotenuse, which is C. So the way for solving for this one is a little different. We're going to multiply both sides by C. When I do that, I have C cosine of 34.5 equals 10.5. To get C by itself, I would divide both sides by that 34.5. So C equals 10.5 divided by cosine of 34.5. And again, have your calculator in degrees. You just type this right in, and you hit enter, and you get the answer of 12.7. We'll round our sides to 1 decimal place for now. So now we're going to get into some word problems. So it says, from a point on level ground 125 feet from the base of a tower, the angle of elevation is 57.2. Approximate the height of the tower to the nearest foot. So we need to create a picture. Obviously, we're dealing with a right triangle because we're talking about on the ground to a tower. So we'll call this over here our tower. We're standing 125 feet from the tower. And the angle of elevation implies we are looking up. So this angle right here is 57.2 degrees. And it says approximate the height of the tower. So the variable of x we would put on the side over here. Because this is my theta, this is my opposite, adjacent, and hypotenuse. This is just a one-step calculation because they just want to know the height of the tower at the end. So opposite and adjacent is tangent. So I'll be doing tangent of 57.2 equals my opposite, which is x, over my adjacent, which is 125. To solve for x, I multiply both sides by 125. Again, you would just type this exactly in the calculator, 125 times tangent 57.2, and we get 193.96. Because we're going to round to one decimal place, this will round up to 194.0, and it's a word problem, so we put units on it. So 194.08. Next example, it says a kite at the height of 30 feet when 65 feet of string is out. If the string is in a straight line, find the angle that makes with the ground. Round to the nearest, I'm not sure, nearest tenth of a degree, that should say of, not O. Okay, so here's my kite, here is the string, and we're going to create our triangle out of that. So let's go back and reread this to kind of get the information. So the kite is at a height of 30 feet, so the 30 feet is here, and 65 feet of string is out, so you're assuming the person is standing here, they have 65 feet that is attaching them to the kite. So 65 feet would be here. And if the string is in a straight line, find the angle it makes with the ground. So the only angle that's on the ground, other than the 90-degree angle, would be the angle closest to the person. So this is my opposite side, this is my adjacent, and this is my hypotenuse. I have opposite and hypotenuse, so that means I'm dealing with sine. So when I go to set this up, I have sine of theta equals opposite over hypotenuse. Notice I don't have the angle this time, so the way we type this in the calculator, you'll hit second sine, and when you do that, it'll pull up the inverse. And then you just input the fraction. Again, you need to be in degrees to do this. Angles will round to or actually the directions say round to the nearest tenth, so we'll round to the nearest tenth for this one. So one-step calculation, they don't want to know anything else about the triangle, so you are done with that one. So for our last example, it says you are taking your first hot air balloon ride. Your friend is standing on level ground 100 feet away from the point of launch, making a video of the terrified look on your rapidly ascending face. How rapidly? At one instant, the angle of elevation from the video camera to your face is 31.7 degrees. 1 minute later, the angle of elevation is 76.2 degrees. How far did you travel to the nearest tenth of a foot during that minute? So let's go ahead and create our picture. So here's the hot air balloon with your terrified look on your face. Here is your lovely friend who is videotaping and documenting everything. And there's your 90-degree angle. So your friend is standing 100 feet away from where you launched. So down here is 100. The first angle of elevation is 31.7 degrees. And we need to find the height at which you are at that moment. So this is opposite and adjacent, so this will be tangent. So I'm doing tangent of 31.7 equals opposite over adjacent. I multiply both sides by 100 to solve for x. Type this in the calculator, you get 61.8 feet. Okay, so now I need to go through and now I remove that 31.7 0.7 degrees. So a minute has gone by, and now in order for your friend to take your picture, they have to tilt their head at an angle of 76.2 degrees. So I'm going to do the same calculation again. I'm just going to use the new angle of 76.2. We're still going to multiply by 100 to solve for x. Type it in the calculator and we get 407.1 feet. So in order to find the answer to the question, they want to know how much did you travel in that 1 minute time frame. So I need to take these two answers and subtract them. And when I do, I get 345.3 feet in the 1 minute time frame that you were documenting. So that's all for today. I apologize the video was long, but there's no way to really shorten these word problems. We'll talk about these tomorrow.